Let's solve this LeetCode problem 912, sort an array. So given an array of integer names, sort the array in ascending number. Okay, here is the constraints here. Okay, so in previous videos, we actually solved this problem using the Quicksort two-way partition. And also, we also used a merge sort. So you can check it out if you want to solve it in two-way partition. But in this video, we are going to solve this problem using three-way partition. Okay. So when we use a three-way partition, we use a three-way partition because sometimes we have duplicate element in the array. So that's why we use a three-way partition. Three-way partition because of the duplicate elements. Okay. So what's Quicksort three-way partition? Three-way partition, the algorithm. So in the three-way partition, okay, the array actually is divided in three parts. Okay, so let's see the first part. The first part, array and the low here, lt minus 1, this is the elements less than the pivot. Okay, and then the second part is array here, array from lt jt. Okay, this elements equals to pivot. Okay, this is the elements smaller than that, this is equal to that, and the C array, the JT plus 1, the high elements, this one is greater to pivot. Okay, greater than the pivot. Okay, this is a basic algorithm for this one. So and then we recursively what we do, we actually after we partition once, and then we recursively do Quicksort from the left portion. So we do this part, and then we do the right portion. The one is greater than that, is greater than the current pivot. So kind of this is the algorithm. Okay, so after we do the kind of Quicksort, and then we choose a pivot. Okay, so the element less than pivot, we put it in the array this arrange, and array lt jt elements equals to the pivot, and the jt plus 1 to the end. Okay, greater to the pivot. So and then after this one, we do Quicksort of this part is we recursively do from start from the low to this one. So we do this part, the elements less than the pivot, we recursively do partition again, and then we do this part. Okay, the elements greater than that one. So this is basically the algorithm. Okay, let me show you an example. We can use this example. The second one, in this case, we do this. Okay, so in this case, the pivot equals to numbers start equals to 5. Let's choose the leftmost one. Okay, this is low, this is JT. Okay, for this problem. Okay, so for this problem, so this one is LT. Okay, Oh, let's make it a little bit sparser otherwise. This one is I, this is initialization. Okay, this one is JT. Okay, so let's do it. So first we check. Here we check the number size smaller than the pivot. In this case, smaller than that. So let's check the numbers 1 equals to 1 smaller than the 5. Yes. If it's smaller, then what we do? If it's smaller, then we do LT. We do we swap I and LT and then plus plus. Okay, so it's gonna be like this. It's going to be like this. So what we do in this problem, we will do this one, we will swap because we're smaller than that, right? So what we do here is 1, here is 5. And then we plus plus, this plus plus 1, the GT we don't change, okay? And then check the I smaller than that, smaller than the pivot, yes. And then we swap this one, and then we plus plus again. So let's do it. So here is gonna be 1, here is gonna be 5, and then we iterate. Okay, the G, we are not iterate G, okay? And then we check the number 2, smaller than the 5, yes. And then we swap this one again. And then here is 2, here is 5. And then we plus plus. The GT is not plus plus, okay? We put it back here. So, and then what we do, we check 0 smaller than the pivot, yes. And then we swap this one. Because it's smaller than that. Okay, 5. And then plus plus. Remember the JT, we don't change the position. So in this case, okay, we can see the elements smaller than LT, the index is smaller than LT, they are smaller than the pivot, and the greater than that is greater than the pivot. But in this case, the JT is end of that. That means there's no the one over there. Okay, the last loop we check 0 smaller than this. Yes, we swap this one. Okay, and this one, and here is 5, and then we do this. But remember, we are not changing the JT. Okay, the JT not moving. Okay, JT and LT, they are in the end of this one, and the I is out of the kind of is greater than the end. So in this way, if greater than the end, then we kind of that's the stop condition. We just return. Okay, and then what do we do? We continuously do this way. We continuously do this. We continuously do this. Okay, this one is gonna be from start from here to LT minus 1 to here. So that means we start from here to here. And a Quicksort from JT plus 1 start from here and to the end. And the end is here. And the start is greater than the end. And then here we just return. We just return the last element is 5. We just return this, okay? We return this, and then we do this. We recursively do, we are going to do here, okay? So what we do, the number's gonna be equals to like this, okay? And then it's gonna be like this. Okay, here, what do we do? Okay, the pivot equals to 1 because This is the first one, right? And then what we do, this one is initialize this LT, this one is I, and this one is JT. Okay? So in this case, what we do? We check one smaller than the pivot, no. Greater than the pivot, no. And then what we do, we add plus plus. Okay? We just add plus plus. The JT don't change, okay? Add plus plus. That means I is here, JT is still here, okay? So and then check two, smaller than the pivot, no. Greater than the pivot, yes. So what we do? If greater than that, if nabs I greater than the pivot, right? So what we do? We swap the I with JT and then JT minus minus. Okay. I will explain why the I don't minus minus JT is minus minus. So after we do that, this one will become like this. So here is 0, here is 2, and then this one we minus minus. So this is after we swap the I with GT and the JT minus minus, the result will become like this. And then we change 0 smaller than the pivot, yes. So what do? We swap this. Okay, if it's smaller than that, then we just actually what do? We swap this one, and the plus plus. That means that this one is 0, this one is 1, and then we plus plus. But remember, the JT we are not moving, right? So in this case, JT not moving, and then we check the I smaller than that. So we just checked 2, and then this one is 1, and then we check this one smaller than that, smaller than this, yes, and then we swap this one. So, and then plus plus. Okay, so what we do, we just put here is a 1, here is a 0, and then we plus plus, but JT is not moving. Okay, JT is still here. So what we do this. JT is still there, right? JT is not moving. JT still here, right? And I still here. So now we check the 2 smaller than the pivot. Pivot is 1, right? It's greater than that, right? So it's greater. When greater than that, so then we are using this one. Okay, when it's greater than that, so what we do, we just actually we greater than that, then we just swap this one to this one, and this one minus minus, right? And then it's gonna be, let's do what gonna be it is like. So we just sweep this, and here is 2, here's 1, and I don't move, and JT move to here, and I still here. Okay, I still here. So in this way, we will check I again. I smaller than the pivot, no, and greater than pivot, no. Then we just add plus plus. Okay, the I is here. Okay, so this basically the algorithm. Okay, and then because I is greater than the end, and then we just return. Okay, so for this case, we can see. Oh, this one we need to actually, the last element, actually, we need to do this. Swap. Right? Yeah, swap, right. Sorry about that. Yeah. We need to actually do this. Okay, 1 second. Okay, let's just start here again. A little bit confusing. Okay, so from here, let's check the I smaller than the greater than this one, right? So we will actually swap this one with this one. It's greater than that, right? So we're gonna swap the this one we actually 1 second here here actually this one is smaller than that one. So we need to actually make sure I smaller equals to JT. We actually make sure I smaller than equals to JT. So in this case, we don't need to do more comparison because I is already greater than that one. So we don't have to swap anything like that. So we just stop like this, okay? We have to make sure I smaller than that, smaller than equals to the JT, okay? In this case, we're gonna continuously do this. We're gonna continuously do this, and here start, and the LT minus 1 is here. We just do this part, and also JT plus 1 is here, and the end is here. That means we just return 2 here because we are equal to that one, and then we just do this part. Start, and we just do this too, okay? This we are going to do. Okay, so when we do this, it's the same as the one we just did. So the pivot is equal to 0. This one is LT. This one is JT. Also, this one is I. So they are in the same position, okay? So that means that I equals to JT. So our while loop is I smaller equals to JT. So in this way, we still go in our loop to check I smaller than and this one, no, greater than this one, no, equals to this one, yes, 0 equals to 0. So in this case, what we're gonna do, we're gonna do I plus plus. So we will do after I plus plus, we'll do like this. Okay, so I greater than JT now, so we stop. Okay, and then we try to do another quick sort. Start from this one. This part is empty, and this one is empty. So we only have this part. So this is basically the algorithm. Okay, so let's coding. So what we do, we quick sort. We do quick sort. We will do this later. Okay, and then we return names. Okay, and then we need to write another function. It's called the Quicksort function. So what we do, we quicksort. Oh, we have to do this. Public. We don't have to return anything, but we just sort it. Okay, we just sorted it for this algorithm. So we just do this. Here's the int and the a int start int and okay, what do we do? We check. Okay, this is a condition, the recursion stop condition. We check if the start greater equals to the end. If greater equals to the end, what do we do? We just simply return. Okay, this is a recursion, the condition. And then what we do, this is the pivot. Pivot equals to, we choose the first one, okay? The first element. Okay, this is the first element. And then we choose I equals to start plus 1, okay? And int LT equals to start. And then int J T equals to end, okay? This is basically this one, and then we do while loop I smaller equals to JT, okay? And then what we do, we just do this. Smaller equals to that. If here is a I smaller than the pivot, okay, we just do you remember when we do that smaller than that, we just swap the I LT and then plus plus, both of them plus plus. Else, if the I greater than the pivot, what do we do? We swap A I J T minus minus. Okay, and then what if the AI equals to pivot? Then we just do I plus plus. We just do I plus plus. Check the next one. Okay. After we do this, after we the while loop, so we recursively do the first part of the from start to the LT minus 1. So the one actually smaller than the pivot is this range, and then we do another one, quicksort A. This one we start from JT plus 1. So the one who is the one is greater than the pivot, okay, to the end, okay. Okay, yeah. Okay, basically this is a quicksort function. And then what we do here, after this one, we need to write another function for swap. So this one, SWP. Okay, what do we do? We just here equals to A int I int J. Okay, and then, oh, not 0. Okay, and then what we do, we just do int temp equals to A. Here is I. Okay, and A I equals to A J, and then A J equals to temp. Okay, and then here we need to put the kind of input the method. So okay, here. Okay, so first we put nambs. The start is gonna be 0. The end is nambs dot length minus 1. Okay, this is the nambs 0, nambs minus 1. Okay, let's check the code. Let's run the code. Then swap A. Okay, here actually what we do should be like this, because this is a method we are trying to. This is a method we are trying to actually call back here. Okay, so let's. Okay, accept. Okay, let's choose another. Let's choose this one. The test case. Okay. Let's run this also. Okay, it works. Okay, so the time complexity for this problem. Did we talk about template complexity? No, not yet. The time complexity for this problem gonna be, oh, not Q. It's gonna be big O n log n. Okay, it's gonna be O n log n. and then the space. Okay, let's submit the code. Okay, it works. We are faster than 32.95% of the Java Online submission. Okay, here the space complexity is gonna be log n. Okay, let's submit the code. Yeah, we just submitted the code. Okay, we are faster than 21.82% of Java online submission for this problem. Okay, thank you for watching. I'll see you next time.